Today I'm going to demonstrate Univa GridEngine running on Google Compute Engine managed by Univa UniCloud. I will use the Google Compute Engine G-Cloud command line tool as well as the Google Compute Engine web interface for this demonstration. UniCloud is a configuration management tool that we use at Univa to quickly deploy Univa GridEngine clusters onto physical and cloud infrastructure. This demonstration assumes that you have a Google Compute Engine account and that your account has enough permissions to create a new P12 key for use later in the demonstration. Now let's get started. After logging into your Google Compute Engine account, you should navigate to the Images section, where you will see two different types of images, a compute node image and a head node image. I'm choosing the head node image. Once I choose that, I use the web interface to set up the name of the instance and other parameters, as you can see on the screen. I'm making sure I set it up in the US Central A region, and then I create the instance. At this point, I wait for Google Compute Engine to launch the instance. And as you can see from the interface, I have an old instance lying around which I'm going to select and delete in a moment, since I don't need that one. So the instance that's starting up is the one with the little icon that's rotating. And of course it's turned green now. And once I check the instance, you can see that I am now waiting for Google Compute Engine to launch. I'm going into the networking configuration just to make sure that the ports are open so I can SSH to it. As you can see, I've set it very open. You probably don't want to do that for your own test demonstration. And then we go back to the status screen. At this point, the instance is up, and I can use the G-Cloud command line interface to list the instances. And then, of course, I can use the G-Cloud command line to SSH to the instance. I'll make it a little easier on myself by using the config SSH command. And then I can just cut and paste that SSH line to connect to the remote Google Compute instance. So this is really the first step in getting the cluster up and running, getting the head node configured. And that is quite simple. It really is just launching the Google Compute Cloud image. Now we can run the qhost command to see that the cluster is up and running, and you can see that the head node is operating as expected. And then once we have the head node configured and that GridEngine is up via the qhost command, I'm going to change to root, show you that a simple command from UniCloud to list what are called kits and the overall node status. And that just proves that the system is operating as expected. And now to make the compute nodes configured, we change to the opt UniCloud config directory and edit the adapter defaults file. This file controls which key UniCloud is going to use, which image it's going to use, and generally how it's going to configure the compute nodes. So as mentioned previously in this demonstration, we need a P12 key so that the UniCloud installer, which is this head node, can provision compute nodes as needed. And so I've already gone and created a P12 key. And you can see here I'm highlighting that that's what you need to do. So the easiest way to go and create this P12 key is to go into the Google Compute Engine web console and then go to Credentials and create a new client ID. I've already created one, and you can see I'm highlighting the signature of that P12 key just to show you that I have one on my machine, my local machine. I'm just going to show you here where I compare the two so you know I'm using the correct one. It's pretty easy to get confused about which key you're using, so it turns out that the prefix of the key name forms a signature, as you can see there. And so you have to copy this P12 key file up to the head node. You may have other ways of doing it, but in this demonstration I'm just showing I'm copying it from my local machine up to the Univa UniCloud and Grid Engine head node. And so once I know which machine to copy it to, I'm going to get that from as you can see, I'm exiting out so I can figure out what the full SSH name is. And then I copy that and paste it so that we can copy the files up. This is a very small file, so it should only take a second or so. Obviously, typing takes longer. Okay, the file is now transferred up onto the instance that is running the Univa Grid Engine head node. And what you need to do with this key is you need to configure it in the adapter defaults GoogleComputeEngine file. And that will involve, of course, just putting that into that key equals value that you see on the screen. One important thing to remember is that you need to edit this resource adapter config file as an administrator or as root. And you have to copy that ComputeEngine key to an appropriate directory. Obviously, you have to give it either a relative path or a full path to the file. We also need the service account email. And to get that, again, the easiest way is to go to the Google Compute Engine web console in the credentials section and copy out the email address. And of course, you paste that into the adapter config file. There are other sections in here. The default service email can remain default. You can change the type of instance, but you definitely need to set the project. And once again, the easiest way to find that project name is to go to the web console, and it is actually displayed at the highest level where it gives you the name of the project. You can get this from the Google G Cloud command line as well, but it's just easier for this demonstration to show you here. And again, paste that into the right location in the adapter config file. There are other parameters here which in general you want to leave, except for the images, because this is the image URL that UniCloud will use to launch the compute nodes. So you go back to the images in Google Compute Engine console. This time select the compute image instance, not the head node. It's important that you make sure you select the correct one, otherwise it just won't work properly. And we need the full URI, so you'll need to click on the rest button, and from there highlight and select the full URI for the image. As you can see, that's what I'm doing here. And copying that and then pasting it into the adapter config file. And you can see there's a few more parameters. It's important to see here that the user that will be enabled on the compute nodes will be the CentOS user, not the root user. That's when those compute nodes are launched. And I'm following along in the simple instruction guide as well, which comes with UniCloud. So now we're going to add the compute nodes to the cluster. In order to do this, we need to use the add nodes command. And the add nodes command needs two things. It needs to know the software profile and the hardware profile. So I'm getting them from UniCloud. As you can see, there's a compute and installer profile for software, and there's a Google Compute Engine and installer profile for hardware. So now we'll add nodes, the software profile being compute, and the hardware profile being Google Compute Engine. And we'll tell the system how many nodes we want to add, which is 3 in this case. So UniCloud will use that previous configuration information in the adapter to go off and launch those instances. So as you can see, it attempts to launch them. And if we go look at the Google Web Console, you will see that the instances are being started. Now, you only see 2 here, but that's really just an artifact of the console. Once I refresh it later, you'll see that 3 are actually being launched. And until UniCloud receives the sort of return OK signal from Google Compute Engine, it will not come back from this launch attempt. It'll take a few moments for it to happen, but once it's finished, it'll come back and tell you that it has launched 3 instances. There we go. You can see it appeared on the shell session underneath this console. There we go. We click to it. You will see the 3 nodes have been added. There they are. And if we go back and we look at the Google Compute Engine Web Console, you'll see that the instances are there too. If we look at the node status in UniCloud, you will see that each node has this discovered active state. It means that Google Compute Engine has launched the node, but UniCloud is still configuring the node. Once it changes to installed active, it means that UniCloud has finished configuring it. So it really does take a few more moments for the system to configure itself. It is a distributed system. It takes some time for the system to install all the components, configure them, and get them up and running. But you can see even now, Grid Engine has those nodes automatically added to the cluster. So we have 3 compute nodes in our Grid Engine cluster. They're just not quite up and running yet. And behind the scenes, Puppet is actually configuring the components on those compute nodes, and then UniCloud is connecting those compute nodes into the cluster dynamically. This all happens behind the scenes, so really it's not something that you typically mess with. And once we refresh, you can see, as I mentioned before, there are 3 compute nodes added to the cluster. So I'm just waiting at this point for things to get stabilized, and as you can see, they're now stabilized. So at this point, you have a working Univa Grid Engine cluster on Google Compute Engine with 3 compute nodes. Now you could add more nodes if you wish, but just for this demonstration, I chose 3. And we're really finished at this point. We have a working cluster. We can actually SSH to one of the nodes because all the keys have been set up. As you see, I've SSH'd here. The next step is actually running work on the cluster. The qsub command submits work into Grid Engine. So I'm going to submit an extremely simple job that really does nothing but sleep. And then I'll submit it a few more times. So you can see almost immediately that job started running. And we'll submit a few more just to fill up the cluster. And of course those jobs have started running. And there are 3 nodes in the system. By default, we're really only running 1 job per node. So the other jobs remained queued and waiting, as you can see. So I can do a more job detailed information. For example, I'm going to look at job 3 in more detail to see how it's running. And that gives you more environment information, submission time, which node the job is running on, CPU and memory information for the job, which of course for a sleep job is really trivial. It doesn't do much at all. The next step is to delete nodes from the cluster once you are finished with them. Using the delete node command, we can use wildcards to delete all of the nodes in our cluster. This will take some time to complete, and I find this is typically the slowest part of Google Compute Engine, the actual removal of nodes from the cluster. So I'm not going to wait for the entire time while it deletes, and I will skip ahead to the point where the nodes are removed. The final step in removing the whole cluster is deleting the head node. You just simply select it and delete it. Once this is done, then the whole cluster has been removed from Google Compute Engine. This concludes the demonstration, and I hope you can see it's quite straightforward to create a Univa Grid Engine cluster in Google Compute Engine with a few simple steps and configuration. If you have any questions, you can contact me at my email, which is displayed on the screen. Thank you very much.